Hello, welcome back to another episode of Following Science, where I delve into the latest advancements and intriguing topics in the world of science and technology. I'm your host, Ritu Parle, and today I'm going to be exploring a fascinating and potentially life-saving innovation, synthetic blood. I'll take you through the history, types, development processes, clinical applications, innovative uses, challenges, and future prospects of synthetic blood. So we have a lot in store today, so let's just dive right in. First of all, synthetic blood is an engineered product designed to replicate and fulfill some functions of natural blood. The journey of synthetic blood began several decades ago with the goal of overcoming the limitations and shortages of donor blood. Today, we see synthetic blood as a promising solution to various medical challenges. Now, synthetic blood, also known as artificial blood, is a substance designed to mimic and perform some functions of the human blood, primarily oxygen transportation. It is not intended to replace all functions of human blood, but it focuses on only critical aspects like oxygen delivery and volume expansion. Now, the need for synthetic blood arises from several critical challenges in healthcare, starting with blood shortages. Like I mentioned before, the blood demand and the global demand for blood often exceeds the supply, leading to shortages. According to the World Health Organization, or WHO, there is a constant need for regular blood donations because blood can only be stored for a limited amount of time before its use. Now, synthetic blood could provide a reliable and sustainable alternative to regular blood. Then there's also transfusion reactions. Donor blood can sometimes cause immune reactions or transmit infections. Synthetic blood could eliminate the risk of these infectious disease transmissions and reduce incompatibility issues. Then there's also universal compatibility. Synthetic blood could be potentially designed to be universally compatible, eliminating the need for blood type matching. This means it could be used in emergency situations without the delay of blood typing and cross-matching. Now, there are several types of synthetic blood, each with unique characteristics and methods of action. Let's explore some of the main categories, starting with hemoglobin-based oxygen carriers, or HBOCs. Now, HBOCs are designed to transport oxygen throughout the body using hemoglobin, the protein in red blood cells responsible for oxygen delivery. Now, HBOCs utilize modified or recombinant hemoglobin, which can be derived from human, bovine, or genetically engineered sources. This hemoglobin is often chemically modified to improve its stability and reduce toxicity. HBOCs can carry and release oxygen in a manner similar to natural red blood cells. Now, some notable HBOCs include Hemopure and Polyheme. Hemopure, derived from bovine hemoglobin, has been used in clinical trials for various indications, including trauma and surgical patients. Polyheme, on the other hand, is based on human hemoglobin and has shown promise in trauma care but faced regulatory challenges. Then there is PFCs, or perfluorocarbon-based oxygen carriers. Now, PFCs are synthetic molecules that can dissolve and carry large amounts of oxygen. Now, PFCs are chemically inert compounds that can dissolve up to 50 times more oxygen than plasma. They are emulsified with other substances to create a stable injectable solution. Now, PFCs transport oxygen by dissolving it in their structure and releasing it to tissues with lower oxygen tension. Oxygen is a well-known PFC-based synthetic blood that has undergone many clinical trials. It has also shown potential in reducing the need for donor blood during surgeries, though further studies are required to establish its safety and efficacy. Then there's also stem cell-derived blood. And this type of blood involves the use of pluripotent stem cells to create red blood cells in the laboratory. Scientists induce these pluripotent stem cells to differentiate into red blood cells through a series of carefully controlled steps. This involves exposing the stem cells to specific growth factors and environmental conditions that mimic natural red blood development. Now, this approach is still in the experimental stage, but holds great promise and potential for creating a limitless supply of blood for transfusions. Researchers are working on scaling up production and ensuring the functional equivalence of these lab-grown red blood cells to natural ones. The development and production of synthetic blood involves cutting-edge research and sophisticated manufacturing processes. Let's delve into some of the key aspects of this fascinating field. Starting with research and innovation. The journey of synthetic blood research has been marked by numerous milestones and contributions from leading scientists and institutions. So let's go right into it. First of all, the initial attempts to create synthetic blood date back to the 20th century, with significant breakthroughs occurring in the 1980s and 1990s. Early research focused on developing HBOCs and PFCs, with advancements in biotechnology and materials science propelling the field forward. More recently, the development of stem cell-derived blood has opened up new avenues for research and potential clinical applications. Then there's also many contributions from leading researchers and institutions. Some of the institutions include University of California, San Francisco, the University of Cambridge, and companies like Sandgart and Himarina. And now these companies and these institutions are at the forefront of synthetic blood research. These organizations are exploring various approaches to enhance the safety, efficacy, and scalability of synthetic blood products. Now, the production of synthetic blood requires precise and controlled processes to ensure the quality and safety of the product. Now, different types of synthetic blood require different production methods. HBOCs are typically produced through recombinant DNA technology or chemical modification of hemoglobin. PFCs are synthesized chemically and emulsified for use. Stem cell-derived blood involves sophisticated cell culture techniques and bioreactors to grow and differentiate stem cells into red blood cells. Then there's also quality control and safety measures. Rigorous quality control measures are in place to ensure that synthetic blood products are safe, effective, and free from contaminants. This includes testing for sterility, functional performance, and biocompatibility. Regulatory agencies such as the FDA and the EMA have also established different guidelines and requirements for the development and approval of synthetic blood products. Now, synthetic blood holds immense potential in various clinical applications, from emergency medicine to surgery and beyond. Let's explore some of these applications in more detail. Starting with emergency medicine and trauma care. Synthetic blood can be a lifesaver in emergencies and in situations where time and resources are critical. So, in trauma cases where rapid blood loss occurs, synthetic blood can provide immediate oxygenation and volume expansion, stabilizing patients until they can receive appropriate care. Its ability to be stored and transported easily makes it an ideal solution for emergency response. Now, there have been numerous instances where synthetic blood has been used successfully in emergency settings. For example, in clinical trials, HBOCs have been used to treat trauma patients with significant blood loss, demonstrating their potential to save lives in critical situations. Now, in surgical settings, synthetic blood offers several advantages over traditional blood transfusions. Synthetic blood can reduce the risk of transfusion reactions and infections. It can also be stored for longer periods and used in patients with rare blood types. Additionally, it can also be administered in situations where blood typing and cross-matching are not feasible, such as in emergency surgeries. Now, while synthetic blood is still in limited use, it's expected to become more prevalent in surgeries as research progresses. Future developments may lead to routine use of synthetic blood in various surgical procedures, reducing the dependence on donor blood. Now, the military and remote medical operations can benefit greatly from synthetic blood, starting with utility in battlefield and remote locations. Now, synthetic blood can be transported easily and used in field hospitals where access to donor blood is limited. Its stability and long shelf life make it an ideal solution for military applications and remote medical operations. Now, moving on to research by defense organizations, defense agencies like the ARPA are actively researching synthetic blood for use in combat and remote environments. These efforts aim to provide soldiers with life-saving interventions in the field, improving survival rates and outcomes in military operations. Now, beyond traditional medical applications, synthetic blood has the potential to revolutionize several other fields. Let's look at some innovative uses of synthetic blood now, starting with space exploration. Now, synthetic blood can provide a reliable supply of oxygen-carrying capacity for astronauts on extended missions, reducing the need for regular blood supplies. In space, where medical resources are limited, synthetic blood can play a critical role in emergency care and maintaining astronaut health. Now, NASA and other space agencies are also exploring the use of synthetic blood to ensure the health and safety of astronauts. Studies are being conducted to understand how synthetic blood can perform in microgravity and its potential benefits for long-duration space travel. Another way that synthetic blood is used is in the treatment of chronic anemia. Patients with chronic anemia can benefit significantly from synthetic blood. because synthetic blood can provide a consistent and effective treatment for anemia, especially in patients who do not respond well to traditional therapies. By delivering oxygen more efficiently, synthetic blood can improve the quality of life for individuals with chronic anemia. Synthetic blood can also be designed to universally be compatible. Now, this makes it a very valuable resource for patients with rare blood types, as I mentioned before, and it can simplify transfusions and reduce challenges associated with finding compatible donors. Synthetic blood can also enhance the preservation of organs in transplantation. So, by providing oxygen and nutrients, synthetic blood can extend the viability of organs outside the body, improving transplant outcomes. This can increase the success rate of transplants and reduce organ rejection. Now, research is ongoing to develop synthetic blood solutions that can be used in organ preservation fluids. These innovations have the potential to revolutionize the field of organ transplantation, ultimately saving more lives and improving patient outcomes. Synthetic blood can also play a critical role in bioengineering and tissue engineering. Synthetic blood can be used to oxygenate and nourish bioengineered tissue and organs, making them more viable for transplantation. This can pave the way for the development of artificial organs that function effectively in the human body. Now, researchers are exploring the use of synthetic blood in creating complex tissues and organs for medical research and therapeutic applications. These advances could lead to significant breakthroughs in regenerative medicine and tissue engineering. Despite its potential, synthetic blood faces several challenges and potential negative impacts. So let's explore these in more detail. Ensuring the safety and efficacy of synthetic blood is paramount. Some synthetic blood products have been associated with adverse effects such as increased blood pressure, oxidative stress, and organ damage. This is why it's crucial to make sure that rigorous testing and clinical trials are happening, because these can help address these risks. Obtaining regulatory approval for synthetic blood is also a complex and stringent process. Regulatory agencies like the FDA require extensive evidence of safety and efficacy before approving synthetic blood products for clinical use. Now, moving on to the ethical and moral considerations of synthetic blood, because it raises some ethical questions, starting with a couple of debates that have been happening on artificial versus natural solutions. There are ongoing debates about the ethics of using artificial products to replace natural biological functions. Some argue that synthetic blood could lead to unintended consequences and ethical dilemmas. There are also concerns about long-term impacts. The long-term impacts of synthetic blood on human health and the environment are still unknown, which is why some ethical considerations include the potential for unforeseen consequences and the need for ongoing monitoring and research. Now, the cost and accessibility of synthetic blood could have significant economic and social implications. The production of synthetic blood is currently super expensive, which could limit its widespread use. Reducing production costs and making synthetic blood more affordable is a key challenge. Then, the high cost of synthetic blood could also exacerbate healthcare inequalities, with access potentially limited to wealthy individuals or countries. Ensuring equitable access to synthetic blood is essential to preventing the widening of gap in the healthcare quality. There's also a risk of over-reliance on synthetic solutions. Overdependence on synthetic blood might divert attention and resources away from natural health measures such as preventive care and promoting healthy lifestyles, which is why it's so important to balance synthetic solutions with holistic approaches to health and well-being. Now, as synthetic blood becomes more prevalent, there is also a lesser emphasis on addressing the root causes of blood-related health issues through preventive care and lifestyle changes, as I mentioned before. Which is why, again, maintaining a balanced approach is, of course, crucial for long-term health. Now, despite these challenges, the future of synthetic blood looks promising. Let's explore some ongoing research, potential impacts on healthcare, and some visions for the future. Starting with ongoing research and innovations. Since the field of synthetic blood is dynamic and continually evolving, we have a lot of things to talk about. Now, researchers are making significant strides in improving the safety, efficacy, and scalability of synthetic blood products. Innovations such as nanotechnology, bioengineering, and genetic modification are paving the way for next-generation synthetic blood. There's also advances in material science, biotechnology, and genetic engineering, which are leading to the development of more efficient and biocompatible synthetic blood products. These innovations hold great promise for the future of synthetic blood. Now, synthetic blood also has the potential to revolutionize healthcare in several ways. Synthetic blood could address global shortages of blood, reducing the risk of transfusion-transmitted infections, and providing, of course, a reliable alternative in emergencies and remote areas. Its universal compatibility and long shelf life make it an ideal solution for various medical challenges. Then, synthetic blood can also complement existing medical practices, providing an additional tool for healthcare providers to improve patient outcomes. It can be integrated into emergency medicine, surgery, and routine medical care, of course, enhancing the overall quality of healthcare. The future of synthetic blood is filled with exciting possibilities. Researchers are currently aiming to achieve several goals in the next decade, including making synthetic blood more affordable, enhancing its safety and efficacy, and gaining regulatory approval for widespread use. These advancements could make synthetic blood a standard part of medical practice. Now, developments in synthetic biology, stem cell technology, and personalized medicine could also be game changers in the field of synthetic blood. These innovations have the potential to transform healthcare, making synthetic blood a vital component of future medical treatments. Now, as I wrap up this episode, let's recap some of the main points I discussed and share some final thoughts on synthetic blood. First, again, as I mentioned before, synthetic blood is designed to mimic and fulfill some functions of natural blood, addressing challenges such as blood shortages and transfusion risks. Again, as I mentioned before, it doesn't fulfill all the functions of normal blood, but it only fulfills the most required ones, such as getting oxygen. Then there are also various types of synthetic blood, including HbOCs, PFCs, and stem cell-derived blood, each with its unique characteristics and development processes. Now, synthetic blood also has various clinical applications, including emergency medicine, surgery, and military use. But beyond these traditional applications, synthetic blood also holds potential for space exploration, treating chronic anemia, organ preservation, and bioengineering. However, despite its promise, synthetic blood also faces challenges related to safety, ethics, cost, and potential negative impacts. Of course, ongoing research and innovation holds promise of making synthetic blood a crucial tool in future healthcare and making it cheaper as well, with significant benefits and potential game changers on the horizon. Now, synthetic blood represents a groundbreaking advancement in medical science, with the potential to save countless lives and transform healthcare. As researchers continue to address the challenges and refine this technology, synthetic blood may become an essential component of medical practice. Now, as we start to wrap up this episode, I hope that it has provided you with a comprehensive understanding of synthetic blood and its incredible potential. Now, of course, I want to thank you all for joining me on this journey into the world of synthetic blood. If you enjoyed this episode, please subscribe to Following Science and leave me a review. I'd love to hear your thoughts and suggestions for future topics. Until next time, stay curious and keep exploring the wonders of science. This is your host, Rutu Parl, and this has been Following Science.